talking about separable differential equations. So what is a differential equation? But it's a relationship between the derivative and the values x and y. Okay, it's telling you the slope and the slope in relation to x and y. And not all differential equations are separable. When we say separable, it means we can get the x on one side, the y on the other. And so today we're looking at the equations that are separable, and that's what we're going to do. We're going to separate them and then find the function that satisfies this differential equation. So, get the x on one side, the y on the other. So here I'm going to divide both sides by y, right? 1 on y, dy on dx is equal to 2x squared. Cheers,
That's alright, it's not high enough.
Okay, now this is a skip we're going to skip. This is a step we're going to skip in the next couple, and I'll show you guys this in our last lesson. But what are we doing is we're performing the integral with regards to x to both sides, right? Okay, so there's what I've got, and I'm integrating with regards to x. And then the same over this side, we can do anything we want as long as we do it to both sides. And then what's going on here, we've got dx at the top and bottom, it cancels. And so the left-hand side becomes the integral with regards to y. All right, we've got integral of 1 on y with regards to y. So we'll form that, that's going to be ln the modulus of y. And on the right-hand side, we're going to have 2 on 3x to the 3 plus c. Now we're going to put e to the power of both sides, right? So I'm going to list this step, but again in subsequent problems we're going to skip it. So I'm going to show you exactly what we're doing, and when we get into the problems we don't absolutely need to show it. So here, e and ln, they're going to sort of cancel one another. That's how we've talked about it before. And we've got the modulus of y. So what does that mean? But plus or minus y. So that means over here we're going to have y equals plus or minus. I'm going to put the plus or minus on that side. And we've got e, and I'm going to separate this into e to the c multiplied by e to the 2 on 3 x to the 3. All right, they have the same base. So we can add those powers together, and in fact we've just done the opposite. Rather than combining them, we've separated them. And so all this is just to simplify it a little bit. So we're going to say y equals a times e to the 2 on 3 x to the 3, where a is plus or minus e to the c. All right, so it's just simplifying the notation involved. So the solutions to this differential equation are of this form, all right, where a could be sort of any real number. Any real number of a, and you differentiate it, it's going to satisfy this differential equation. That's our solution. All right, so we're just going to reiterate this a couple of times. So over here, we've got x squared take 4 multiplied by 3y plus 2. So we want to get the x terms by themselves, the y terms by themselves. So let's divide both sides by this whole bracket, this whole multiple here. So we'll have 1 on 3y plus 2, dy on dx is equal to x squared take 4. All right, and then I'm going to integrate both sides with respect to x, okay? So what are we going to have? We're going to have ln modulus 1 on 3, so 1 on a, ln modulus of 3y plus 2. And then over this side, we'll have x to the 3 on 3, take 4x plus c. Okay. First step will be to multiply both sides by 3 to get rid of that third out the front. Now we don't need to change the value of c, okay, because it is just some constant. So we haven't dictated its value yet, so that's fine, we can stay as C. It wouldn't be wrong to write 3C, it's not wrong to just write C. Okay, we'll put e to the power of both sides. So what we're going to have then is 3y plus 2 is equal to e plus or minus e, and I'll split it. Alright, any questions about that step? Okay, so then, now I won't substitute a yet, because we're just going to want to perform the most simple notation possible. So we're going to keep processing it till the end, and then we'll define a. So we're going to have 3y is equal to plus or minus e to the c, e x to the 3 take 12x, and then we're going to have take 2 at the end, and then we'll divide both sides by 3. Alright, and now we'll find a. Where so just a quick recap. We isolate the x and the y components. We integrate both sides with respect to x. Okay, so here the dx's will cancel, so we're integrating with regards to y. This is what we obtain on the left, this is what we obtain on the right. Multiply both sides by 3. We put e to the power of both sides, and that's going to give us the plus or minus. And here I'm splitting it, right? I'm splitting it so that that is just a number. E to the power of c, c is a number, so e to the power of c is going to be some number. We don't know if it's positive, we don't know if it's negative, so we're leaving that open to every possible differential equation. And we subtract the 2, then we divide by 3, and then we perform the a substitution. Very good. Let's move on to the next one. I'm going to multiply both sides by y squared. We shall integrate both sides with respect to x. Multiply both sides by 3. And then form the cube root of both sides, or put both sides to the power of a third. Alright. Now in D, so typo, at the bottom it's supposed to be the square root of y, not the square root of x, should be the square root of y. Okay, so we separate, multiply both sides by the square root of y. Now y dash, that means the same as dy over dx, so just getting you familiar with both notations. So we're going to have y to the half, alright, that's the square root of y, multiply both sides by. And then this y dash is dy over dx, and that's cos squared of x. Now if we're going to integrate cos squared of x, we need to perform the double angle substitution. So we learned that in 7a of integration. And so cos squared of x can be written as half plus half cos 2x. Alright, so cos squared of x is equal to that. Okay, integrate both sides with respect to x. So the integral of y to the half is going to be 2 on 3, y to the 3 on 2. Alright, so y to the n plus 1 on top of n plus 1, that's how we obtain that. So we're getting quick at doing that kind of thing. And then over this side we're going to have half x plus, and I'll do this one slowly, half times the integral of cos 2x is going to be 1 on 2 sine 2x. and we'll just keep processing here. Okay, so now it's just a matter of simplifying. 2 on 3, y to the 3 on 2 is equal to half x plus a quarter sine 2x. I'm going to multiply both sides by 3 on top of 2 to get rid of this 2 birds out the front. So we're going to have 3 on 4x. 3 on 8 sine 2x. Okay, we've got y to the power of 3 on 2, so the way we get rid of that is we put both sides to the power of 2 on 3. Oh, we missed the plus c. Where should I put that? When do we integrate here? Plus c, plus c, plus c, plus c. And then we're doing e to the power of 2 on 3. Alright. Now just in terms of like roots, just to refresh your memory on that, if you have a to the m on top of n, alright, what does that mean? It means the nth root of a to the power of n. So that could be one way we could write it. It is this whole thing squared, but the cubed root of it. Alright, that would be one substitution we could perform. Okay, so in all of these circumstances, we've been able to isolate y. Any questions about it so far? Cool. Alright, let's move on to the next page. So I quite like this exercise. It's a lot of fun, sort of algebra, rearranging, you know, stuff we've been doing for a long time. So first up, we've got show that 4 on x squared take 1, 1 on x take 2, take 1 on x plus 2. Show that. Okay. So whenever there's a show that, it means you're probably going to be using it. Alright, so it means look at this, you're going to use it later on. That's the reason they get issued. The other thing is, this is worth 1 mark. Okay, so you really need to show all the steps. Okay, show all the steps. So we're going to start with the left-hand side, and we're not going to just start by manipulating it, we're going to state what is the left-hand side. The left-hand side is 1 on x take 2, take 1 on x plus 2. Okay? Then the next step.
Yeah, you put the wrong side to.
Right-hand side, thank you.
There goes your mark.
My left and right and stuff. Next step, we're going to multiply both sides by the opposite denominator, right? We're cross-multiplying. So we're going to have x plus 2, take away, x take 2, on top of, x take 2 times x plus 2. Okay, that's the cross-multiplication of the denominators. At the top, we're going to be left with 4, and at the bottom, it's going to expand to x squared. And like, we FOIL it out, x squared take, might want to x squared take 1, x squared take 4x, and then it'll be plus 4. No, it's not x squared.
Difference of 2 squares.
Difference of 2 squares, x squared take 4. Okay, so I think I've made a typo right up at the top. Okay, that's what we should be starting with. Okay, so that's what we're showing, okay, and all it needs is those 3 steps, but don't miss any of them, okay? Because you're given the opportunity to get an easy mark, make sure you show all the communication for it. All right, part B, find the particular solution to dy on dx is equal to 4y on top of, and here it repeats, it should be x squared take 4, given y of 0 is 5. Okay, so x squared take 4 at the bottom, because we're going to need to use the link. Okay, so if we're solving a differential equation, right, we need to get the y component and the x component by themselves. Now there's a temptation here to divide both sides by 4y, okay? And so if we did that, up the top here we would have 1. But that's not going to work for us, because then that's going to be different from what we have over here. However, if we just divide both sides by y, I'm going to have 1 on y, dy on dx is equal to 4 on top of x squared take 4. And that's what we need. We need it to be expressed like that, because that's the substitution that we're going to perform in the moment. We don't know how to integrate this unless we know how to split it into those 2 requisite components. Okay, so I'm going to make the equality statement first, and then I'm going to perform the integral. So this is equal to 1 on x take 2, take away 1 on x plus 2. Integrate both sides with respect to x. Okay, e to the power of both sides. So what we're going to have here is we're going to have y, and then over here we're going to have plus or minus e, hang on, before we do that, let me show you one thing we're going to call it. So let's do it all through this. We've got e to the ln y is equal to e to the c, e to the ln modulus of x take 2 on top of x plus 2. Okay, we have ln a take ln b. What do we simplify that to? ln of a on top of b. Okay, and when we get rid of the modulus, we're going to have y equals plus or minus e to the c. And this part, because we've got the plus or minus here, the modulus just becomes x take 2 on top of x plus 2. Okay, we can perform the substitution. So y equals a, x take 2 on top of x plus 2, where now that's the general solution for the differential equation. Alright? So that describes a could be any value, but we want a particular solution. So not the general solution, we ask for the particular solution that passes through this point. When x is 0, y is 5. So we're going to have 5 equals a times minus 2 on 2, so negative 1. So therefore a is negative 5. And therefore the particular solution to this differential equation that passes through 0, 5 is minus 5 times x take 2 on top of x plus 2. Y equals. Splendid. So it's a fun exercise. Let's enjoy it. That's what we're going to work on today.